lesson in geometry is on circle angles. I know that doesn't make a lot of sense because circles don't have angles. You'll see what I mean in a minute. We're going to do two things. We're going to talk about inscribed angles and circumscribed angles. Okay, so I'm going to start with inscribed angles. By the way, as I go through this, make sure you take notes as I put things up, put definitions down, same thing you would if you were in class. Okay, inscribed angles it's actually, they are angles written in to a circle. So let me draw a circle here. Scribe means write in Latin. In is in, so it just means written in. So what you do is you put the vertex on the circle, and you have an angle like that. This is called an inscribed angle, the angle right here. The arc which it cuts across over here, which goes from here to here, remember that's an arc, arc measure, that's called the intercepted arc. Make sure you draw that picture. So just a definition up here. An inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle, meaning they cut across it in some way. Okay, so how do you find the value of this arc? I'm going to draw some labels on here. First of all, there's A, B, we'll call this D. The angle A, D, D, B, which is the inscribed angle, is 1/2 of this arc measure. So for example, if this arc measure, remember arc measures are measured in degrees. If this is 40 degrees, for example, this angle is 1/2 of it, or 20 degrees. And if you have the angle, the arc is double it, just goes the other way. Okay, I'm going to give you some problems in that just to see that you understand it. I'm going to leave that up there. Actually, I'll leave the formula up. Inscribed angle equals the 1/2 the measure of the intercepted arc. Okay, so let me draw a couple figures now. So there we go. This is 90 degrees here, a right angle, and I'm going to put some labels on this. S, Q. This is R. I'll put a point out here, T. Okay, so the question is, if this is the angle R, what is this arc? This arc is, so angle itself is 90 degrees. That equals 1/2 of the measure of the arc, which is arc in this case, STQ, like that. So what is this angle? It is twice, that cancels out, twice the angle. In other words, if this is 90, this is 180. If I happen to have this is 180, this would be 90. Now if this was 180, this also means that this line here is the diameter. Because this is 180 degrees, 180 degrees is 1/2 the circle, so we basically cut out 1/2 the circle by doing that. Okay, let me give you another example. Put some letters on it, NPM. Now I'm going to give you the measure of the arc. It's 100 degrees. If the arc is 100 degrees, what is the measure of this angle? It is 50 degrees, 1/2 of it. Let me do one more and have you guys do it. Okay, I'm going to put some letters on it. Z, W, X. What I want you to answer is, what is the measure of arc Z, W, x. Okay, pause the video here. Think about that. Write the number down like you're doing on a whiteboard or a piece of paper in class, and then pause it. Okay, come back. This is simply twice this 115. 2 times 115 is 230 degrees. So this arc is 230 degrees. All right, so let me give you one more. All right, a big circle again. I'm going to put a few in this time. Let's say this is 40 degrees, the measure of the arc. I want you to tell me what this angle is. I'll call it A and B. I want you to tell me what measure of angle A is and measure of angle B. Okay, pause that again. Okay, if you come back, hopefully you got the answers for these now. This is just half that. That's 20 degrees. And that is also 20 degrees. And by the way, no matter how I connected this to the circle, this would still be, if that was C, measure of angle C would be equal to 20 degrees. No matter where I put this, it's going to be 20 degrees, as long as I have that same arc. Okay, now I'm going to do a series of theorems on inscribed angles. This is actually the first one. So theorem 1, I think I have 3 total, says that if two inscribed angles have the same intersected arc, the angles are congruent. So in other words, it's just the picture I had before, really. This is A, that's B, measure of angle A must equal measure of angle B, because they have the same arc. Okay, second theorem, so theorem 2, says that if a right triangle is inscribed in a circle, the hypotenuse of the right triangle is the diameter of the circle. So that just comes from this same idea that the inscribed angles have to measure the intercepted arc. So if I draw this, in other words, I've got a right angle here. Oops, that doesn't look very right. I've got a right angle here, and a right triangle. This is 90 degrees. That means this is 180 degrees. And therefore, that means that I've split the circle in half, and this is the diameter. Okay. So pause the video and make sure you write that picture in there to go with that theorem. And then I've got one more theorem, one more to go. So I'm going to write that down below this. So the third theorem is if a quadrilateral, a four-sided figure, is inscribed into a circle, the opposite angles of the quadrilateral are supplementary, or they add to 180. Okay, what I do here is pause the video, write that down, and then come back, so I'm going to have to erase these to actually do the picture for that. Okay, so I'm going to erase these now. I still have a picture under theorem 3 that I'm about to draw. So what I'm saying in that regard is if I have a quadrilateral, a four-sided figure, like that, inside the circle, that this angle, say this angle looks like it's about 100 degrees, the one across from it has to be supplementary to it, or 80. If this one, for example, looks like it's about 100, maybe it's about 100 as well, let's just say it's 95 degrees, the one across from it has to be 85 degrees. In other words, these have to add to 180, and so do those. This is different than a parallelogram, where these two next to each other would add to 180. What that means is you can't actually fit a parallelogram into a circle, unless it happens to be a rectangle or a square, because These, you can see, aren't going to add to 180 unless they happen to be the same. Okay, let me give you some problems on this, on those theorems. Okay, I'm going to say this is a diameter. And then the question is, what is that angle? That uses the second theorem, which says this has to be a right angle, no matter what these two are. And that's because this outside here is 180 degrees. Okay, let me give you another one. I'm going to put two angles in here. I'm going to say this is, looks like it's almost 90 degrees, so I'll make it 90 degrees. And I'll say this one is, I don't know, 100 degrees. I want you to put the other two angles in the figure. So pause the video and try to write those in, and then come back. All right? So if this is 90, this also has to be 90. I know my picture doesn't really look like it, but it is. If this is 100, this has to be 80 degrees. So that these add up to 180, and those add up to 180. Okay, that's inscribed angles. The next one we're going to do is inscribed angles. And then I'm going to talk about some applications for these. So now we're going to talk about circumscribed angles. There you go. So scribe again means right, circum means around. So in this case, a circumscribed angle means it's an angle outside the circle, and it goes around the circle like that. So let me write that down. A circumscribed angle is an angle whose rays, at least only one of them has to be necessarily, are tangent to the circle. If you remember what tangent means, it means that if you had a radius out here, this would be hitting at one point. It would be a right angle. Okay, I'm going to label this just because I'm going to put a formula up in a moment. This is P, Q, R, and then I'll call the angle part, let's call it S. All right, the equation for this, finding this angle, is the measure of angle S in this case. Actually, we put all the letters in there. PSR. That angle is 1/2, in this case, not 1/2 the arc, because there's actually two arcs. It's 1/2 the outside arc, which is PQR, the measure of that, minus the measure of the inside arc, which is PR. Remember that if you have 3 letters, you're talking about the major arc. It's bigger than 180. If you have 2 letters, that's PR. If you have 2 letters, it's the smaller arc. So this is the bigger arc minus the smaller arc. So let me write that up here, because we're going to do some problems with it. BSR. Actually, I'll write it with just names. Circumscribed angle equals 1/2 the measure of the outside arc minus the measure of the inside arc. So have both of that. Have that and that written down in your notes. If you have to do that before I go on, pause the video to write it down. Okay, now we're going to do an example of a problem on this. I'm just going to leave the figure here. I'm going to say the measure of the outside arc, looks like it's about 220 degrees, so I'll just say it's 220 degrees. Measure of PQR is 220 degrees. That's again the measure of the arc from here all the way to here. It looks like it's more than half the circle, which would be 180, so 220 seems reasonable. Okay, and the question is, what is this angle? So first of all, you need the inside arc. However, you can get that easily because this touches at one point. So the inside arc, PR, is 360 degrees, the whole circle, minus that 220, which is 140 degrees. So if this is 220 from here to here, this is 140 from here to here. Okay, now the measure of angle PSR, which is this angle right here, is simply equal to 1/2 the outside arc measure, which is 220, minus the inside arc measure, which is 140. This is, what is that, 80? Half of 80 is 40 degrees. So this angle is 40 degrees. Again, once you have one of the arcs, you can find the other one. And then the angle is just half of that minus that. Okay, I'm going to erase those. Have you do them. Just going to erase the numbers. So 140. Now I'm just going to do the same thing, except I'm going to say the measure of this arc, P, Q, R. Did I say last time 220? This time we'll say it's, I don't know, 240. Okay, so what I want you to find is first find a measure of angle PR and then angle S. And pause the video, try to do that on your own. Okay, if you're back, angle S is going to be 240 minus the inside arc. The inside arc is 360 minus 240, or 120 degrees. So the arc is, the angle is just 1/2 of the outside arc, which is 240, minus the inside arc, which is 120. 240 minus 120 is 120. Half of that is 60. So this example is 60 degrees. Okay, let me give a couple applications of this before we go on. So one of the biggest ones is satellite technology. So let's say I'm going to draw a picture of the Earth here. And I've got a satellite. Let's say I have a Hughes satellite, which is a little smaller here, because the Hughes satellite is way far away from the Earth. Let's say I've got a Hughes satellite, a DirecTV satellite over here. And I want to know how many satellites do I need to cover the Earth. That will depend on how far I'm away from the Earth. But what you do is you create a, this is what DirecTV can actually interact with. Like that. So if it's far enough away, like really super far away, you can almost get 180 degrees. If it's not, you're only going to get, you know, maybe a third of the planet. And you get that from doing this calculation. In fact, what DirecTV does to cover the whole planet, the problem is, let's say I draw it in here, I'll draw a little different scale. If it's way out here, it's predicting the planet, it's going to hit like a third. Let's say this is a top-down view of the Earth. In other words, here's the North Pole up there. It needs other ones to hit the whole Earth. In fact, it can't just have even 2, because then it's going to miss the parts over here and here. So you're going to miss part of the Earth. So what it actually has is 3. It has one like right over here, one over here, and one over here. And it does this. Oops. And that covers the entire Earth. Now remember, the Earth is 3D, so it's still actually in this case going to miss the North Pole and the South Pole. But they don't really care about that because they don't need people to watch it. So this is what they actually do. DirecTV, they have 3 satellites equally spaced around the Earth that are revolving constantly around the Earth at the same speed as the Earth actually. And then they cover the entire planet. So that's one very practical application for it. Let me give you another one. This one I think I talked about before, but if you are here and you're a certain person on the top, out here, the question of how far you can see again out is also an inscribed or circumscribed angle problem, because you've got a tangent line, and you can see from both directions. So what percentage of the Earth can you cover? It'll be your certain height here. The arc measure of that minus that will give you the angle here, and you can calculate. If you have the angle here, you can actually calculate this arc and this arc, and you know see how far you can actually see as a percentage of the Earth. All right, that's it. Let me do a little summary first, and then I'll give you the homework. So, summary. So we have inscribed angles. Which are like this. And if, say, this is, I don't know, 80 degrees, this is half of it, 40 degrees. That's basically it. By the way, a big application I didn't really talk about when I got there, a big application of these is actually lenses. You can see that kind of looks like an eye. That's actually a big application of inscribed angles. Not just eye lenses, like how you shape glasses and things like that, but also camera lenses. There's also video lenses in application. Okay, so that's the inscribed angle. Then we had some theorems behind that. Let's do a little shorthand. Theorem 1, Theorem 2, and Theorem 3. So Theorem 1, remember, just said if I have an arc and I've got more than one angle off that same arc, these angles are all congruent. Because this angle saves 40 degrees, that'll be 20, that'll be 20, and that'll be 20. Theorem 2 says that if I have a diameter, that I create a right triangle in here, or if I have a right triangle in here, I create a diameter there. And then finally, Theorem 3 says if I put a four-sided figure in there, then these two angles have to be add up to 180, as do those two. Okay, that's inscribed angles. Then circumscribed angles. Angles. That's really poor handwriting. I'll write it again. Says that, oh, I missed a formula up here. Sorry. The measure of, for inscribed angles, the measure of the angle inscribed is 1/2 the measure of the arc that it intercepts. And then circumscribed angles, it's an angle outside, could go through by the way as well. A, B, C, D, E. This one says that the measure of angle, the circumscribed angle, circumscribed, which in this case is E, is 1/2 the outside arc minus the inside arc. There we go. A little messy summary, but let me go through it again. Inscribed angles, the measure of an inscribed angle is 1/2 of the arc. That's what I drew over here. Theorem 1 says if I have an arc, I can put angles off of it any direction, and their inscribed angles are all the same. Theorem 2 says if I put a right triangle inside there, this is the diameter. Theorem 3 says the angles across in an inscribed quadrilateral are supplementary. Circumscribed angle says the angle of an angle outside is 1/2 the outside arc minus the inside arc. All right, homework. So for homework, if you are in geometry, there is a worksheet called Inscribed and Circumscribed Angles. Angles worksheet. If you're in advanced geo, do the worksheet. Plus there are a couple book problems. Challenge problems, page 786, 35 through 37 all. And the SAT problems on that same page, 40 through 43 all. So there's your homework. Until the next lesson, thanks.